Good.
All right. Well, hello and welcome to the Psychophiles podcast. I've got the wonderful Olivia Duchaquette and Marshall Lester with me, as well as the wonderful professor of ours, Dr. Lucas Jones. So, Luke, the first thing that I really wanted to know about you is that because you're a vision researcher, you do work with perception, you work with sensation. So that's what the course we've first been introduced to you was about. How is it that you would go into a field like that, coming from a place where, in school, you don't really learn about sensation, you don't learn about perception, you don't learn about the underlying neural mechanisms that you would then research in your position. So I'm curious to know a little bit more about how it is that you got into this field in the first place.
Okay. So when I did my A-levels, I did sciences. But when I was looking to apply to university, I wanted to do something different. I wanted to do something I hadn't studied before. And like a lot of other students, I probably had a misinformed idea about what psychology was about. So I had this idea that it was like, either mind reading or hypnosis. But I was also interested in the biology side of things. And biology was something I was quite strong at school. So that was my initial interest. But how I got, I do visual perception, but my main research area is time perception. I got into that for quite a strange route. So when I was at university, my third year project was on parapsychology. So in the late 90s, it was a weird time. So the sort of pre-millennium, you have to ask your parents about it, but in the pre-millennium, there was this kind of weird interest in the paranormal. Like most popular TV program at the time was X-Files.
So like ghosts.
Yeah, all that kind of...
I hear a presence.
Yeah, it was all mixed up in the zeitgeist of the pre-millennium. Yeah. So there's this kind of feeling of like the apocalypse was going to be. And then the Millennium Bug was... we were heading some kind of threshold.
Yeah, in the year 2000.
Yeah, all of that.
Every computer would break then.
Yeah. And it's like this affected psychology as well. So there was a resurgence in interest in parapsychology. So psychologists being interested in paranormal experiences. This is going somewhere. In my third year, I did a module on parapsychology. I didn't believe in the paranormal, but that wasn't the point. The point was that paranormal experiences are part of the human experience, and they're worth investigating as to where this stuff comes from. So we were doing an investigation on telepathy.
Okay.
And we are using sensory deprivation, or a form of sensory deprivation called the Ganzfeld technique.
Okay.
So essentially, you put somebody in a soundproof room. They listen to white noise. They have pink or red light shining on them. Okay. And this is supposed to induce a hypnomombic state, which is associated with visual hallucinations, and supposedly is associated with people having clairvoyance. So it's a brain state you often have when you're first waking up. And people who report having visions of the future often report it comes in dreams or when they just wake up. So the idea you would try to put people in this state and then get them to receive images that are being beamed to them.
Wow, that's crazy.
Yeah, it was really interesting. What was invaluable about it was that it really taught you the experimental technique, because if you were to find a result, then you needed to make sure that you had control for every possible variable that could possibly have leaked that information into that person. So it was quite a good training exercise. The experiment didn't work, but what people did spontaneously report when you put them into states was, so they'd be in it for half an hour, they would spontaneously report that didn't feel like half an hour. It only felt like 10 minutes.
That's interesting.
Yeah, and I thought that was interesting. And I went to look this up. I don't know anything about time perception. We hadn't been taught anything about time perception. So I went to the classic cognitive psychology textbook, which I should have read by that point, and looked at time perception, and there's no entry for it. So then later on, when I was looking to do a PhD, when you're looking to do a PhD, you try to find an area that hasn't been trampled to death already.
Of course.
And I sort of had an interest in this time perception idea anyway. So and by coincidence, studentship opened at Manchester.
Okay.
In time perception.
Mm-hmm.
And that's how I ended up.
Wow, interesting.
Yeah.
That's fantastic.
And can I just ask, for people who maybe are less familiar with this kind of area of research, what does it mean to study sensation and perception, or perception and action? How could you it might be a difficult question, but how could you summarize that area of research?
That's a good question. So what you're interested in is the difference between the two. So the sensation is the thing that you can physically measure, the energy that's coming into the system, whether it's photons entering the eye or it's vibrations in the air entering the ear. The perception is the interpretation of that sensation. And the two aren't the same. And there's a great mystery about what the perception actually is. Let me give it an example. I've just been teaching the first years about sensation and perception. So colour's a good example. So light enters the eye, and the photons hit the photoreceptors, and inside the photoreceptors there's a chemical, and the photon bleaches this chemical. It changes the permeability of the cell, and this fires an action potential to the brain. And you see, from the output of these different receptors, you perceive a range of different colours. But there's nothing coloured about the light coming into the eye, and there's nothing coloured about the electrical signal going to the brain.
That's right, yeah.
The colour is purely a perceptual phenomena. It's your brain's interpretation of the sense. This is true of all the senses. So trying to understand, your brain is basically trying to backward engineer what is it out there in the real world that's causing this electrical signal that I'm receiving. You're only aware of the real world by definition, through your senses. So your brain is constantly trying to have to solve this, or come up with a hypothesis about what it is out there that's causing this. And sometimes the hypothesis is wrong, which is where you get vision illusions, or sometimes the information is ambiguous, so you flip between one interpretation and another. Classic example is like the Necker cube.
Right.
So the sensation is remaining the same, the input to the system is remaining the same, your interpretation of it is flipping between one hypothesis and another. So that's the perception. The sensation is the same, but the perception is different. So in terms of experimental psychology, it's a similar thing. You have, if you design your experiment properly, you have complete control over what you're putting into the system in terms of the stimulus. You have instructions which you give the participant, and out of it you get the data. And between the two, you try and interpret something about what's going on in between, especially the whole, trying to decipher what's going on in that black box. And there's different approaches to that. So most of what I do is psychophysics. So I'm interested in the computation that's going on in the brain between that input and the output. Other people are interested in the mechanism. So you might try and look directly into the black box by using some EEG or using fMRI. But really, it's all about the same thing. You have control over the sensation, and you're trying to get at what the perception is, or how the perception is constructed or created.
I was going to say, could you tell us more about that you said psychophysical kind of approach? What does that mean? How is that different from, I guess, like observing the brain activity with EEG and things like that?
So you're trying to, so psychophysics was an approach that was popularised in the 1970s. And it was basically taking a reverse engineering approach to the brain. So they started off by looking at something called power laws. A chap called Stevens and Fechner. I'm going back into ancient history now. But, they were interested in the relationship between sensation and perception. So for example, if I play you a sound and I get you to rate the loudness of the sound on a scale from 1 to 100, and I increase the volume of the sound, I can look at the relationship between the thing that I can measure and your sensation of it. And as you might know, for sound, it's not a linear relationship. To start with, very quiet sounds, you'll notice an abrupt change in the loudness. But then as it gets louder, I have to really ramp up the volume before you notice any increase in volume at all. But other sensations have a different relationship. So if I give you an electric shock, for every little increase in the current, your rating of the sensation will increase by a large magnitude. And there's I won't do it. There's an equation you can have between the thing that you're measuring, you're putting into the system, and people's psychological rating of it. And there'll be an exponent that explains the relationship between the two. So if you know what that number is, you know what the relationship is between the two. So if the number is less than 1, which it is for sound, then you know that you've got this kind of
logarithmic.
This diminishing returns. If it's larger than 1, then you know that you've got this kind of exponential increase, like you have an electric shock. If it's exactly 1, then you know you have a linear relationship between the two. So the beginnings of psychophysics was working out all of these
relationships.
These power laws. Later on, people took a more advanced approach to that. So you could have more complicated stimuli going in, and you could get people to make decisions about stimuli coming in. So are these two stimuli the same? Or which one is brighter? Or is this one the same as the one I gave you 5 minutes ago? And then you can construct more complicated boxes and arrows diagrams about what you think is going on computationally in the brain. So they're taking in this information in forms of the stimuli you're giving them. They're applying some demand that you've given them, and you're getting the data out. And you're trying to infer something about the operating characteristics that's going on inside the brain. So in a nutshell, that's psychophysics.
Wow, that's really fascinating. So I'm curious how you bridge time perception from this basis. So you have these basic underlying laws, which you're referring to, and some of them are have different relationships between them. So sound may be different to seeing, and maybe different to touch as well. And so then you have something like time, which I suppose isn't really a sensation at all. So you're going full into perception at that point. And so I assume it's more theoretical, more abstract, what you're doing there.
Yeah, that in a nutshell is the difficulty of the area.
The photon of time.
Yeah, exactly. There isn't some sense organ for time, but we talk about people having a sense of time, a sense of duration, as if it is a sense. And also going back to the power law, the relationship is a linear relationship between duration and objective duration and subjective duration. So because there isn't some energy called time going into the system, people have proposed that people have an internal clock mechanism.
Right. Yeah.
You have some internal generator of events, and you use that in order to time.
Yeah, so essentially like a self-perpetuating clock.
Yes.
I know that there's some theories, especially in sleep science, where somewhere deep in your your base brain, you have self-perpetuating neurons, right?
Yes, and so the type of time perception I'm involved in is slightly different from sort of circadian rhythms. So there's lots of those types of 24-hour cycles of different chemicals, or body temperature, sleep-wake cycles, hunger cycle, that kind of thing. I'm more about the perception of duration. So, for example, if I play you two notes on the piano, and I ask you which note is longer, or play 2 tones and ask you which is longer, you can easily tell me which one is longer.
Right.
But your precision is more precise than most people realise. So you can detect differences in the order of tens of milliseconds.
Oh wow!
Hundreds of a second. So that suggests that you have some very fine mechanism for detecting differences in duration. And people have suggested that we have some kind of internal clock mechanism for doing this. One of the pieces of evidence is that you can mess around with the speed of this clock.
Okay.
So one of the things I do in experiments is I use repetitive stimulation. So you might be given a series of clicks or a series of flashes of lights. And then if I give you I give you an event, and I ask you how long was that event, you'll perceive the event as being longer if it's preceded by repetitive stimulation. But it's not that you're sort of including some of the repetitive stimulation in the thing,
Mm-hmm.
because the effect gets greater the longer the duration is.
It's almost like it's being exhausted,
Yes,
whatever that resource is.
it's been sped up.
Yeah.
So if you plot estimated time against real time for the click condition and the no click condition, you get a difference in slope between the two. The effect gets greater the longer the duration is. So this is consistent with the idea that you've sped the rate of something up.
Mm-hmm.
So let's say if you have two cars leave Manchester at the same time, one's travelling at 30 miles an hour, the other's travelling at 60 miles an hour, the longer they go for, the greater the difference between the two.
Mm-hmm.
You also get this slope effect for the timing in different senses.
Okay.
So if I get you to estimate tones versus lights, that's also a slope effect.
Mm-hmm.
Or if I get you to estimate empty periods of time with filled periods of time, you get this slope effect. But that's also a bit of a mystery.
Yeah.
Because you think that one of the advantages of having an internal clock would be that it wouldn't matter what you were timing. You should get a consistent.
Right.
And this is one of the things I'm interested in at the moment. So I suspect that might not be the case.
Mm.
It might be, and some other people have suggested this, it might be that what's actually going on is that, so the classic sort of clock is you have a pacemaker, a switch, and an accumulator. That's the simplest kind of clock you can have. So you have whatever it is, you have some internal generator of pulses, ticks, oscillations, whatever it is, and you have some way of measuring them. Now that's consistent with, I said before, that the relationship between objective time and real time is one. It's a linear relationship. If I double the amount of time that you time, your estimate also doubles.
Yeah.
And that's consistent with linear accumulation. If you're accumulating something with time, then that would make sense.
Yeah.
But it could be that the pacemaker isn't internal. The pacemaker could be sensation, which is then being accumulated.
Is that your hypothesis, that it's more out there in the world?
I think it's possible. Lots of people have historically objected to the idea of an internal clock. The problem is, whatever you replace it with has to do all of the tricks that human beings can do.
Right.
So not only can they tell very easily that one duration is longer than another one, they can also do mathematical operations. So I can give you a duration, and then I'll give you a load of other durations and say, right, what percentage of this duration is that? And again, you get a very orderly linear relationship. Or you can get people to time a duration and then stop while there's a gap, and then carry on timing. So they can use this thing like a stop clock.
Yeah.
Plus you have these different rates issues. So whatever you replace it with has to be able to do with these tricks.
Yeah.
Now some people have tried to replace it with a qualitative rather than a quantitative model. So one idea was that you had a particular brain state, or want of another word, that's associated with a duration. I won't go into all the details of it. But let's
like
say
a feeling of sorts, huh?
yes.
Okay.
Let's say one idea is that you have a bank of oscillators, and when you time a duration, these oscillators have different periodicities.
Yeah.
And so while you're timing the duration, they're all going from a positive to a negative phase at different rates. And at the end of the duration, they stop. And whatever state these different oscillators are in, whether it's a positive or negative, produces a pattern of pluses and minuses.
Yeah.
And that's your representation of, say, 15 seconds.
Okay.
So you should be able to recognize when you perceive 15 seconds.
Okay. Yeah.
I'm simplifying a little bit.
Yeah.
Now that sounds quite nice, but because what people often object to is this accumulation thing. It seems biologically weird. But the problem with having that kind of model is that because there's nothing more encoded, it's just a different pattern, then that kind of system can't tell you that. It can tell you that 2 seconds is different from 1 second.
Yeah.
But it can't tell you that 2 seconds is longer than 1 second.
Yeah, right.
Nor can it perform any of these mathematical operations I said before. And also, it gets even worse because the representation of 15 seconds could be more similar to the representation of 2 seconds than it is to 14 seconds. Because there isn't more of something being encoded. And there's been lots of attempts to replace the internal clock with models like this, but they all fall at first. But what's actually seems to be critical is not so much the pacemaker, but the accumulation. The pacemaker could be anything. What you want is something that linearly accumulates. So it could be the processing of sensory information. So you have sensory information coming into the system. I mean, I've no evidence for this, but you basically process in some way. And so, if you like, the outside world is the pacemaker.
Yeah.
So this might explain why you get these differences in timing for different, and particularly the largest effect you get in time perception is a difference between timing and a period of silence and a period that's filled with a tone or a light or something. And as you might guess, the filled interval seems longer. So if it is based on processing of information, well, there's obviously more sensory information in a filled interval than there is in an empty one.
Right.
So it seems to go in the right direction. But then that would, but is there more sensory information in a sound than there is in a light? Perhaps in an experiment where you're giving a very simple stimuli, a tone versus a green triangle on the computer screen.
Right.
But what's actually going on in real life is it's more difficult.
Yeah, of course. And I have two things that come to my mind when you said that. The first is that surely there has to be some multimodal processing going on, because in some ways, you know that a lecture may last an hour. And even if you wouldn't necessarily feel that it lasted an hour if you didn't have any context prior to that, you know that it was an hour. And so you just kind of say that. Maybe in relation to that, you said all these other things. So I wonder if these kinds of multimodal effects affect time processing and those underlying, like the flow of time, the perception of the flow of time.
Okay, I don't know.
Okay.
The flow of I should have pointed out something else earlier on. So that a lot of what I've been talking about so far is about the perception of duration. So how long a stimulus or an event lasts for.
Yeah.
And we have these internal clock models, and we have good mathematical cognitive models of how we think this is done, and we have good characterization of how good people are. I've also done work on touch, timing of touch as well. Some work I did with Professor Polyakov.
Oh yeah.
So that's all quite well defined, and whether you believe in an internal clock or not, we have a very good characterization of that system.
I see.
There's a whole other issue of time perception which I'm interested in, which is the human experience of time perception.
Right.
Which I think is what you're hinting at.
Yeah.
So we all have this feeling of time either speeding up or slowing down, either dragging or crawling by, depending on whether you're having a good time or whether you're having a miserable time.
Exactly. Yeah.
And everybody relates to this. But we also know that time always runs at the same rate, unless you're very close to a black hole. It always runs at the same rate. But people don't think you're mad when you say this.
Yeah.
So we tend to pass all those judgments out in the field. It's a fairly recent phenomenon. We now call those passage of time judgments.
Okay.
And when people are talking about perception of time, it's often very critical to work out whether they're talking about a perception of time, whether they're talking about a passage of time judgment, or whether they're talking about a duration judgment. And it gets more complicated because some passage of time judgments are duration judgments in disguise.
I see.
If that makes sense. So you might say to someone, I was waiting for that bus for hours. Now that sounds like a duration judgment of how long you're waiting for the bus, but that's not what you mean.
Yeah.
You're saying
it felt
like time was going really slow, or it felt like a long time. So this difference between these feeling judgments and these duration judgments is critical. I've done a fair amount of media work and bits and pieces about time perception. And a lot of the questions people ask tend to fall into the passage of time.
Because it is very interesting to understand.
Yes.
Okay, why is it that waiting for the bus seems so grueling and long, even though you could then go on to spend 3 more hours than you would waiting for the bus on some event, and it feels like no time at all.
Yeah.
So where is it also that you pay attention to that time mechanism that affects it, or
yes, that's a good question. So one model of it is that what determines the speed at which time flies is your attention to time. Although what attention to time means
it's also complicated because we don't even know what attention is really.
But there's a model by a chap called Zakay, which is quite useful for thinking about these things. So he argued that any situation you find yourself in can be characterized by time relevance and temporal relevance and temporal uncertainty.
Mm-hmm.
So if we take the example of waiting for the bus.
Yeah.
So if you need that bus to arrive on time to get to a lecture or a doctor's appointment or to get to the airport, then time relevance will be very high. And if you're catching, not so much, Manchester's not too bad, but depending on what bus you're on, you might have a high level of temporal uncertainty about when is this bus going to arrive. Yeah. So the higher temporal relevance is and the higher temporal uncertainty is, the slower time will seem to pass.
Wow, that's interesting.
Because you'll probably be pacing up and down the bus stop, and you'll be looking at your watch or your phone every 5 minutes, and you will wonder, when's this bus going to? It's agonising. But if I reduce one of those, then time won't pass as slowly. So for example, if there's reliable information at the bus stop about when the next bus is coming, if the next bus will be here. We don't have it on buses. But if you wait for a tram, it's fairly reliable information. So if you know that your tram is definitely coming here in 7 minutes, then that reduces the anxiety and it reduces the temporal uncertainty.
Right.
So time won't drag quite as much. You won't be attending to time quite as much because you're not thinking, when is this thing gonna happen?
Yeah. So I wonder if there's like a temporal equivalent to those lines you have on the highway, where because you have these really dense lines near exits, you feel that you're going faster than you are.
Yes.
And maybe there's the same thing with time, where if there's a lot of interspersed moments, so to speak, which you have to pay attention to, then it feels longer. Whereas if you just have this long space in between the things you're thinking about, then it feels like it's no time at all. Like if you're working for 4 hours and you're really into it, then it doesn't feel like any time.
Yes, because you're not attending to time, and that's one of the things I'm interested about. Is about whether these passage of time judgments are in any way related to the internal clock mechanism, whatever it is. And people have done experiments on this, and it's originally when they were parcelled out as being separate judgments, it was supposed that they didn't have anything to do with each other.
Okay.
That the speed of time passing was really to do with whether the situation was pleasurable or painful.
Okay.
So you're using time as a way of expressing to somebody else, how pleasant or unpleasant that experience was. And it didn't have anything to do with the internal.
That's interesting. Okay.
But this model of it said about temporal relevance and temporal uncertainty, that model was actually proposed before we separated out these passage of time judgments. That was actually supposed to be a model that was about the internal clock. And it was about how much attention you were devoting to time. The more attention you devoted to time, whether it was your internal clock or clock on the nobody wears a watch anymore, right?
I do have a watch.
It's both of you. It's very unusual.
Because we have our phones. So
it's gone to the phone. So it was supposed it was about the attention to the clock.
Yeah.
So I'm interested in this relationship between the two. My suspicion is that there's two types of passage of time judgment. One that is related to this internal clock mechanism, and one that isn't. There's more of a I mean, the interesting thing I think about the time speeding up and slowing down is that you're only aware of the slowing down, not the speeding up.
Mm-hmm.
So if you're in a situation where time's dragging, you're aware of it at the time. But if you're in a situation where time's flying, you're only aware of it at the end. It's only when I get a phone call from my girlfriend when I'm down the pub that I realise that it's 10 o'clock and I've been there. While I was there sat drinking, I wasn't aware that time. It's like a mismatch between what time my brain thinks it is and what time it actually is. Whereas if time's crawling, you're aware of it.
That's interesting. That's really interesting. Recently, I've been reading a little bit of Daniel Kahneman's work, and he made the distinction between the experiencing self and I think it was the recalling self, so the self that kind of looks back at itself in time. And I wonder whether there's a connection between I am in the present moment and I'm feeling these things and I'm bringing to memory all these little temporal cues, or I'm looking back at all those cues and I don't really see many things there. So maybe it wasn't that much.
Well, that's very interesting because that's something else that is troubling, but is a bit of the puzzle that doesn't quite fit. So in the laboratory, we can make a distinction, which is what you're talking about really, between prospective and retrospective judgments. So if I get you to come into the lab and I tell you, right, pay attention to this piece of music. At the end of this piece of music, I'm going to ask you how long the piece of music was. So that's a prospective judgment. You know you're going to be asked this question.
Mm-hmm.
If I then repeat the experiment, but I get someone to come in and I just say, right, listen to this piece of music, and I ask them, an unexpected question about time, I will get a different pattern of results. So there's a difference between prospective and retrospective judgments of duration. And typically, I'm going to undermine this in a minute, but typically, the more demanding the task is, in the prospective condition, it will seem shorter, and in the retrospective condition, will seem longer.
Mm-hmm.
So the idea is that in the prospective condition, like you're being told, like, pay attention to time, but I'm giving you some other tasks to do. I'm dividing your attention. I'm taking your attention away from time towards whatever the secondary task is.
Mm-hmm.
And the more I take your attention away from time, the shorter you'll think that interval was.
Okay.
Which makes sense. If they're prospective time and they're using their internal clock, and this internal clock requires some attention, and I give you some difficult secondary task, I'm taking away attention for time, so your judgment will get shorter.
Yeah.
In the retrospective condition, it's the opposite. So in the retrospective condition, you didn't know you were going to be asked this question. So you're supposedly you do it by inference. So for example, if I ask you now, how long have we been talking?
Mm-hmm.
You didn't know you were going to be asked that question.
Right.
But you would probably base it on how much material we've covered.
Yeah, exactly.
You make an inference. And people, and this is a common thing, people make judgments about how long you've been doing something by, how many scripts have I marked, how far have I walked.
Exactly.
So you get this clear difference between prospective and retrospective timing in the lab. But what on earth is going on in real life? Mm. Because in real life, you're not cued, you're not deliberately told, right, pay attention to how long this thing lasts. Yeah. So are you doing prospective timing all of the time, or are you doing retrospective timing, or a mixture of both? And this is something I'm very much interested in.
Really?
Okay. Because it can't be that this prospective, this really precise timing mechanism that you've got only kicks into action in a laboratory when you're told, right, pay attention to how long this thing is. Exactly. Yeah. So my guess is that we are. Yeah, sorry, do you want to? Yeah.
No, continue.
Okay. My guess is that we are prospectively timing all of the time, but the attention to time varies. And so it might be very high in some situations where you're waiting or anticipating.
Yeah.
So the example I always give in the lectures is you're crossing the Oxford Road and you press the button to wait for the green man. Mm-hmm. And it seems to take longer for the green man to appear than it normally does. Now, that's interesting because that tells you two things. It tells you that on some level, after you press that button, you are timing how long it took the green man to appear. Mm-hmm. And also that you carry around in your head a memory of how long it normally takes the green man to appear, or an average time of how long it normally takes the green man to appear. And you're comparing how long it took now to then. Mm-hmm. So in that situation, it seems as if you are doing prospective timing. Yeah. But in other situations, you're paying less attention to time. So the reason why I was going to undermine this prospective retrospective thing in the lab is it's supposed to work like that. So the more information processing you do, the shorter the prospective judgments. That almost always works. But the retrospective timing, sometimes it works and sometimes it doesn't. So my PhD supervisor, Professor John Weirden, he left here and went to work at Keele. And he spent a few years exclusively investigating retrospective timing. And he drove him crazy not literally crazy, but he drove him around the twist.
Scientifically crazy.
Yeah, because he designed one experiment that increased the amount of information processing, and it lengthened the retrospective judgment. He'd do some other manipulation, it had no effect at all. And he couldn't find a pattern of what on earth was happening here. But if, as I suspect, the retrospective time, if we're doing some low-level prospective timing all of the time, then maybe it's that this retrospective timing is getting contaminated with prospective timing. Okay. So perhaps in a situation where, so let's assume it's true that your attention to time varies on a continuum. Perhaps when it gets really low, then you do start relying on the amount of information processed, or the amount of stuff done, or the amount of memory you've got. So that's in that situation, the experiment works because they paid so little attention to time that they're forced to rely on the mechanism you think is in operation. But if their attention is higher than that, then they're going to be doing some kind of prospective timing, so the manipulation doesn't work.
I see.
And that feels more right to me, because as you said, you can't just have this mechanism just to exist in experiment. It must be taking part in everyday life. So that's one of the things I'm interested in learning. I'm generally interested in trying to not get out of the lab, but see
how it works in real life.
Yes, what's actually going on in real life. Yeah.
Really interesting. That's so fun. Sorry. I was going to ask, because you've talked about looking at the different modalities, so different measurements of sensation with either like flashes of light or sound, when we're going back to not the passage of time judgments, but rather the more precise clock that we have. But I was wondering if you've done work, or if you're just generally interested in work around the idea that there's variation in the participant rather than the stimulus that is changing time perception, more so going back to its passage of time judgments, in terms of either age. So if like judgment on passage of time changes over the course of the lifetime, or other demographic features that would alter that. And if you have any interest in that area.
Yes.
Do you? So what insights could you tell us?
Okay, so how time changes as we age is a really interesting question. So almost everybody says that time gets faster as they get older. So if you, people have noted that people have always said this. And one idea that gets repeated to me over and over again, as if it's an original idea, and you probably thought this yourself, is that a year is a smaller and smaller ratio of your life as you get older. I looked into this thing. This idea has been around for so long. In the psychological literature, it first appears in the 1950s, I think. If you go back to look at journals in the 1950s, they're quite interesting because they don't have any data. These are people just
philosophers.
Yeah, essentially.
Greek philosophy.
So the letters they're basically the manuscripts are in a form of a letter that's been written to the chairman of whatever club it is, over a glass of port. So someone, coming up with their ideas about time. I can't remember the name of the author, but in this journal, there's someone saying about this, and then there's another article in the same journal, someone disagreeing with it. But neither of them got any data about this.
Wow, that's crazy. Because I've heard about this.
Yeah.
And I was thinking,
this idea kicked around for ages. And then there was a chap called Loftus. I forget his name. But he actually went out and asked people this to actually get some data. So what he did, he asked people to say, how quickly does time pass now compared to when you're half your current age? And how quickly does time pass now compared to when you were a quarter of your current age? And he found that, yes, it did get faster as you get older, but it wasn't a simple ratio effect. In his data, he found that you had to be 4 times as old before he said that time went twice as fast. So it didn't quite ramp up in this way. There was then some other work in the late 90s by a chap called Mark Whitman. He's quite a famous psychologist in other fields. He works in time perception. I think it was part of his PhD. He got a massive cohort, 300 or 400 people of various ages. I think the oldest person was 99.
Wow.
and got them to rate how quickly has time passed now compared to when you were younger. He just said younger. And he found that, yes, people did rate it going faster, but actually it seemed to peak in middle age rather than exponentially increasing.
That's interesting, yeah.
So you wonder whether some of it is actually wrapped up to do with, what was another word, midlife crisis. That as you approach middle age, you start assessing where you are in your life in terms of relationships or your career or your wealth or whatever it is, or just general happiness. And if you're dissatisfied in some way, then you're then where time is flying by. So maybe it's wrapped up with your sense of mortality. There's a bigger issue here, which is although everybody agrees with this notion, and you can ask people questions about it. Do people? Is it a truthful question or a truth? If I ask you now, how quickly does time pass compared to when you were 12 years old? Okay, you'll give me an answer, but do you really carry around in your head a memory of how quickly time passed when you were 12 years old or 20 years old? Or what? You can ask people that question, and they'll give you an answer. That doesn't mean that the answer is actually meaningful, or that it continues to go faster. There's also some studies that have looked at elderly people, and it's not everybody says the same thing. And one of the predictors of how quickly or how slowly time seems to pass was actually quality of life. So elderly people who didn't have much going on would often describe that the days dragged, but the weeks flew by. Which is it's an interesting. So they're saying something really about the quality of life. So the days drag because they're not. That's an example of the passage of time judgment. They're not. They're bored, or they're not getting much social interaction. But they might say the weeks fly by because they get to the end of June or whatever. They look backwards and nothing happened. It's kind of like a retrospective judgment, but it's an empty period because they just did the same thing, or it was. And that might be part to do with it as well. So when you're younger, you have lots and lots of novel experiences. So when you look back over that period of time, it seems like a long period of time. But when you get older, you tend to we're creatures of habit. You tend to do the same thing at the same point of the day, or the same point of the week, or the same point of the year. So the years kind of merge into one. When you look back over the last 10 years, it doesn't seem like 10 years because there's not as many distinctive things to remember. The other classic one is people say Christmas comes around quicker every year. Everybody agrees with this. But that's really odd as well when you think about it, because why don't you update your model of how long a year is? Well, why are you caught out by this every single December? You'd think you'd learn at some point. Okay, well, actually, Christmas comes around pretty quick. But why are you taken by surprise by this? And it's not true of children. For children, Christmas can't come around quicker.
Right, of course.
So what you might be talking about a little bit with Christmas is your relationship with Christmas changes as you get older. So as a child, it's the most exciting thing in the world. As an adult, it's more of a mixed bag. It can be quite stressful. You've got to buy presents, and you've got to go and visit family members.
You have to make food.
You have to make food, and it's expensive, and you might have to meet up with estranged family, which can be quite stressful. So you're not anticipating Christmas. So it comes around quicker every year because you don't really want it to come around quicker every year.
Yeah.
So the reason why I said it is it's interesting when people talk about time that it's mixed up in a lot of other things that don't really have anything to do with time. But we do. What's common about it is that we all use time as a way to express to other people something intrinsic about how pleasant or unpleasant, or how much we're anticipating or dreading, and we use time as a metaphor to
right. Like I can't wait to meet you again.
Yeah,
that's really interesting.
Yeah, can I just try and test my understanding, see if I can summarize it well? Because I've kind of noticed two correlates of perception of time, the speed of time, and one is like the emotional valence of whatever is happening. So things that you enjoy more go by faster, and things that are kind of more miserable, or even maybe that links with the anticipation in an anxiety kind of way.
Yes.
And when you're waiting for the bus, you have this level of anxiety that makes it seem like it's long.
Yeah, that would be the same for the child. So the child, Christmas has a high temporal relevance because they want it to happen.
Yeah.
So time will go slower. Whereas it's something that if there's something they are dreading, then they will have low temporal relevance because they don't want it to happen.
Yeah.
So I interrupted your question.
It's okay. I was going to say, and the next correlate that I've picked up from what we've been talking about is like kind of cognitive load in a way, like the amount of stimulation. Yeah. So if somebody has a lot of different aspects of stimulus at once, time goes by more slowly, I guess, because the brain sees that as a correlate of time because more things are happening.
Yes. Whereas
if it's kind of empty, you kind of get through it faster. And so I guess that's kind of interesting because it's those two things can kind of be the opposite. Because if you're bored, that's a negative emotion.
Yes.
But it's a correlate of there being low stimulation. So maybe I wonder if that kind of explains why you see the days as dragging on, but the weeks going by really fast, because you have a correlate of time that makes it feel fast and a correlate of time that makes it feel slow.
Yes.
Does that kind of?
Yes, I feel. Yes. So you're back to the time in the moment and the time retrospectively.
Right. Yeah.
Yeah. So in the moment it crawls, but when you look back on it, there's nothing there.
Mm-hmm.
I mean, it's a classic of prisoner's dilemma, if you like. So let's say you've got to serve 10 years in prison. Now you could spend every day filling it with interesting, exciting events, so that it seems to pass more. Yeah, occupy your time, so it passes more quickly. But when you get to the end of that 10 years, you'll see why that 10 years was really long.
Right.
Yeah.
Or you could do the opposite. So you do as little as possible.
Yeah.
But the days will drag. That 10-year sentence is going to drag.
Yeah.
But when you get to the end of the 10 years and you look over the 10 years, it might seem shorter because nothing happened.
That's so interesting.
Yeah, that's right.
And you can think about that as a bit of being, that's what your life is like as well. It's a double-edged sword. Do you want your life to pass quickly or slowly?
Both.
Yeah.
No matter how you perceive it in the final analysis.
Yeah, while you're in it. Yeah.
That's really, really interesting. And so if I may, I wonder if you've gotten any sorts of insights into your own life, because as you mentioned, maybe there is something to do with, maybe there are some lessons coming out of time perception research that we should be applying in our own lives. And so I'm curious if you've gotten anything personally out of such research.
That's a good question. I suppose I'm more aware of the factors that are affecting my. If time is crawling, I'm more aware of why is this? Why? It's because I'm dreading this thing, or there's some uncertainty about when this thing is gonna. Those two things, temporal relevance and temporal uncertainty. I think that's a really good model. Mm-hmm. I've not thought of a situation yet where that doesn't explain it.
Yeah.
Although, having said that, it's quite a fuzzy model because, yes, you can say that one situation it has more or less of the thing, but how much more?
Yeah, exactly.
How much slower will it go?
Mm-hmm.
That becomes a bit more murky. What else? What are the insights? I suppose trying not to be in too much of a routine. The routine is so comforting.
Yeah.
I know that I always do the same thing on a Sunday. I'll do the cryptic crossword, and I'll have a roast dinner, and I'll have a little snooze in the afternoon. Like that's Sunday.
Yeah.
But it just means that every Sunday is the same.
Yeah. So just adding a little bit of chaos.
There have been people who have deliberately tried to manipulate it. So they've deliberately tried to make each day as distinctive as possible to see whether it alters their perception of time, and it does. So you're trying to eat different meals, eating different meals at different times, wearing different clothes, just trying to mix up their routine. But then what you really achieving, I don't know.
Sometimes routine is nice.
Yeah, exactly. Yeah, the comfort of routine.
Yeah.
But yeah, it will affect your perception of time. It doesn't matter. Don't know. What have I gained? I don't know.
Yeah. So with that, I'm curious. because you've mentioned that the model that we've proposed, the two-factor model, where we've gotten both the present sense of time and the large sense of time, that it's good, but it's kind of fuzzy. And I noticed that in many psychological theories, that's kind of the problem. Mm-hmm. It's that they may describe it well, but they don't lead to any hypotheses that are easy to test and work in all the cases. So I'm curious if there's some movement in your area to try to kind of operationalize it further. So maybe try to understand some n-gram sort of pattern that helps understand time, and whether that could be extended to people's wider perception. So kind of bridging that, neural basis with the broader interpretation.
Okay, well, I'm the wrong person to ask about neural models.
Okay,
it's not my strong suit.
Fair enough.
And on some level, sounds a bit coarse. On some level, I'm not interested.
Yeah, fair.
I've never really been that interested in the mechanism. I'm interested in the computation. I think things are changing now, but I also think, this is just not political thing, but personal thing. I think neuroscience has overpromised and underdelivered.
I see. In that, what we're talking about, which is bridge the gap between.
But I think things are changing now. I think people are more holistic in their approach, rather than just focusing on one thing or the other. There have been searches, for a biological correlate of this internal clock model, which has not worked out very well. Once upon a time, it was simple. So the human time perception field originally came out of animal work. Mm-hmm. So the human time perception stuff is actually relatively recent. It was only really in the 70s and 80s that any models were proposed. But there was a preceding period of behaviourism in general.
Yeah.
And I don't know how much you or people listening to this know about behaviourism, but one of the things that people were interested in was different schedules of reinforcement. Mm-hmm. So the classic is you have a rat in a cage and you have a lever, and you want to train the rat to press the lever. But what do? You feed the rat when it presses the lever. So that would be a one-to-one constant schedule of reinforcement. Right. So every time the rat presses the lever, you give it a reward. Mm-hmm. Another type of reward would be to reward it for every 10 presses it makes. Mm-hmm. That'd be a different schedule of reinforcement. Mm-hmm. Another one you could do would be what's called a variable interval. So you would reward them on average every 10 presses, but it could be on press 1 or it could be on press 100. Mm-hmm. It's called a variable schedule of reinforcement. This is actually the schedule that's used in gambling.
Yeah.
So if you play on a slot machine, that's you're experiencing variable reinforcement.
Yeah.
And just like gambling, you get these runs of where you're winning all the time, and then these runs where you get a bad strip. The poor old rat, it presses the bar 200 times, it doesn't get a reward. So depending on the schedule of reinforcement, you get different activities. So if you give an animal variable reinforcement, it presses, it goes mad for it. It's like being addicted to gambling.
Yeah.
Another schedule of reinforcement is called a fixed interval. Now, this is where you reward the rat for pressing the bar, but only after a certain period of time has elapsed. So let's say it's 30 seconds. So you turn on the lights in the cage.
Yeah. Oh, yeah.
And the rat, if the rat presses the lever straight away, it doesn't get a reward. The first time it presses the lever after 30 seconds, it gets a reward. And the rat quickly learns, ponders this thing. It realises that there's no point pressing this bar as soon as the light goes on.
Yeah.
So it waits a period of time, up to 30 seconds, and then it starts pressing the bar, give me my reward. Now, the fact that the rat does this at all means that the rat is timing the interval. It has, and this is basically where the time perception field came from.
Oh wow!
Because they realised that the rat could time this interval. So this rat must have some kind of internal clock mechanism. And then they found that you could alter the speed of this rat's clock by using dopaminergic drugs. Oh, wow. So if you give a rat a dopamine agonist like amphetamine, its internal clock will run faster. So if it's previously learned a 30-second schedule, it will start responding at 15 seconds because its internal clock is running faster. Mm-hmm. if you give it an antagonist, like haloperidol, it slows down its internal clock. So it's previously learned a 30-second read. It won't start responding until 45 seconds.
Mm-hmm.
So there was good evidence that the internal clock in rats was dopaminergic in some sense.
Yeah.
And that's still true. But when it came to human beings, we assumed that we would find the same thing. So for a while, it was assumed, well, yeah, this internal clock is in the basal ganglia and it's dopaminergic. But the evidence didn't stack up. It's an interesting tale, actually, because it's one of those classic kind of biases or file draw problems. So because the evidence was so strong in the animal world, people expected it to find it in the human work. So if you didn't find it in the human work, it was very difficult to get the stuff published.
Mm-hmm.
And this became a self-perpetuating thing. And one of the issues was Parkinson's disease.
Mm.
So you would think if the internal clock was dopaminergic, well, the best place to look is Parkinson's disease, because you have to be like 80% or something deficit in dopamine to show symptoms to be diagnosed. So people went out and did timing experiments on Parkinson's disease patients and found deficits in timing. But when you actually looked at the papers, all of the experiments involved a motor component. So they hadn't separated out the two. So in the early 90s, again, Professor John Weirden did some experiments in Manchester on Parkinson's patients, both on and off medication, with age-matched controls, gave them a bank of timing tasks, and found no deficit at all. Whether they were on medication, off medication, they had full records of their diagnosis, or matched for IQ, all of this, found no evidence of it. So you think, oh, well, fantastic, that puts that to bed.
Yeah.
But no, the trouble he had publishing this work was incredible, because there was such a vested interest in the field of that you should find this effect. So it eventually got published, but I've been telling me about peer reviews. Like they threw everything they could at this. Yeah, well, your Parkinson's disease patients weren't ill enough, or there was something wrong with the diagnosis, or the control. They weren't off the medication for long enough. All these objections that weren't being raised at the studies that did find the deficit, but was only at this thing.
So a sort of global confirmation bias.
Yeah, and I've had a similar. This has repeated itself in some work I did a few years ago with autism. So I'm just rambling on a bit.
No. It's really fascinating.
So similar situation arose. So a few years ago, I kept reading articles saying that people with autism had problems with time. And this has been repeated quite a lot. And I thought, okay, this is interesting. What problems do they have with time? So we started off doing a systematic review. I had a PhD student at the time. He was interested in this. Let's start off by doing a systematic review. Let's look at all of the studies that have ever looked at time. That was a keyword. I can't remember the keyword search. We brought up all the stuff. Okay, and we went through it all, and we looked at the type of timing that was investigated, and whether they found an effect in autism, and whether they were children with autism, or whether adults with autism, and all of it. And we found, on the type of timing that I'm talking about, internal clock, perceptual duration, we found little or no evidence that there was a deficit in timing. It was an absence of evidence rather than evidence of absence. Hardly anybody had looked at it. There did seem to be good evidence that they had higher order issues with time, or time as a concept, or about getting ready to be on time, or to have a feeling about whether events are very close to you in time or very far away from you in time. There'd been more work on that, but there hadn't been hardly any work looking at duration. I mean, this is gone off a slight tangent again. This is also similar with imaging or with patient studies. What quite often happens is that someone is involved in a particular patient group, say with Parkinson's disease or autism, but they're not involved in the time perception field.
Mm-hmm.
So they might be interested in time perception, and they'll access this patient group. They think, what should we do today? Okay, let's investigate time perception in Parkinson's disease patients. Or let's investigate timing in autism. But they're unaware that there's already a field of time perception research. So what they'll do is that they'll invent some timing task.
I see.
So the results of it are sort of uninterpretable or uncomparable to results.
Ungrounded, essentially.
Yeah. And this happens a lot. It's something I talk about on the master's course. And the same thing happens with imaging. Maybe it happens now, but it certainly happened a lot earlier on. When people got access to the fancy whiz bang machine that cost $2 million, like, what are we going to do with this thing?
We got to do something.
Yeah. So they'll do. Let's investigate time perception. So they're investigating, but they wouldn't. When they wouldn't bother to actually go and find out what timing task, what task should we use.
Yeah.
So on the imaging masters, I talk to them about this. So if you're ever involved in this, just go and find somebody who works in this field.
Right.
They'll be delighted to help you out.
Seriously.
And they'll tell you what task you need to use, so your results are comparable to the rest of the field.
Yeah. So it's almost like there's a common language
Yeah.
that you can speak with other scientists in those other fields.
You don't need to reinvent the wheel. It's already there. And also, it's an ethical thing. You're wasting equipment, or you're wasting the time of this clinical group.
Of course.
So back to the autism thing. So we applied for and got a 3-year SRC grant. We investigated adults with autism and matched controls. We gave them a bank of different timing tasks, and we found no deficit.
I see.
To be fair, we didn't get that much resistance in the publication, but it did cause
a stir.
Okay. Because certain people's careers, but their research it was invested in this idea that they had a deficit in timing. But we showed that they didn't have some fundamental deficit in their perceptual system.
Yeah. But
we did a follow-up thing where we did a survey of parents of children with autism and asked them about does your child have any issues to do with time and timekeeping? And it was like, yes.
Okay.
It was like an avalanche of, yes, this is a serious issue, particularly around getting ready for school. And there was, we published this stuff, but so there was clearly an issue that was there. But to just simply say people with autism have a problem with time is a non-statement. What do you actually mean by that? Because they don't have some fundamental perceptual deficit.
Right.
Have you done any work out of curiosity because it's a similar phenomenon amongst people that have ADHD?
Yes.
And attention disorders as well as autism, which kind of exists on a spectrum as it's now conceptualized of. But is it a similar finding there as well, where individual duration tasks are fine, but it's the longer step back perspective?
That's a good question, because after the autism work, that was my next thought. I thought, well, let's just do the same thing again. Let's do a systematic review of timing in ADHD. But somebody's already got their head of me.
Okay.
So, but I've not actually read a lot of that literature, so I don't really know the answers. But yes, somebody out there is already on the case for that. Yeah.
Where do you stand now on it, if you don't mind me asking, with autism, and kind of why we see parents certainly, and then also individuals that have it, stating that they have trouble preparing for events, but then their individual task performance seems to be unchanged compared to controls?
So I think it's more of it's some kind of higher order level of conceptual things about time that's being altered. There's no deficit in the physiological mechanism, brain mechanism for timing, whatever that mechanism is. Which is something positive that came out of it, because you would then think, well, if they're having a problem with time on a higher order level, that should be something that we can address, because they don't have some fundamental perceptual issue with time.
Right. Like psychologists can talk about those things.
Or almost the distinction you see there. If one system's kind of impaired, but the other one seems unchanged.
Yes.
Really interesting.
Or it might be the two top rates, which are the top. Sure. But at least we've shown that they don't have fundamental deficit in terms of biology about concerning
in some ways that's empowering.
Yes.
Of course, it's always useful to know the truth about things,
Yeah.
so that allows you to then be able to tailor things like interventions more effectively, rather than just assuming that it's a chemical issue.
You're zeroing in on what
Exactly.
exactly is the issue.
Right.
And in the bank of tests we gave them very low level perceptual stuff.
You could just
Obviously, sort of, we had very low level perceptual stuff. We also gave them sort of higher order tasks. So there's a task where they had to lay a table for a meal, and they had to you got to make the cup of tea while the bread toast. There are a series of procedural things they had to do. They had to be timed at different. They had no problem with that either.
I see.
Wow. Yeah, so it was interesting.
Yeah. So pivoting a little bit, you've mentioned earlier that you're more interested in the computational side of perception and sensation, and so I'm curious whether now with the advancement of computation and the advancement of tools we have available to model the brain and to understand underlying neural processes and hopefully one day perception as well. And if that's an area that you're currently interested in or you're exploring more into, because I remember I think it was in our first year, but it may have been this year as well that you talked about this. You were talking about VR and how it's advanced significantly over the last few years with the Oculus and all that stuff.
Yeah, so that I'm not involved at the moment, but I hope to be. I think VR might be a useful tool for bridging this gap between laboratory and real life. So, to state the obvious, the reason why we do things in the laboratory is you have perfect control over all of the variables. But the flip side is it's a very ecological, artificial environment.
People typically don't go into a very black room. Where
Exactly. If you're doing a visual, sitting there in a chin there, it gives you very precise control. And when going back to the being very controlling about what you're putting into the system, and then measuring the data and inferring something about what's going on in this. And so you need that level of control. But then when you go out into real life, you're getting closer to the real experience, but you can't. The amount of variables is so infinite, you can't really control anything. So you would think that maybe VR would be a if and when it's good enough, would be a middle ground, because you could have an ecologically what seems like a realistic environment, but you have complete control over all of the parameters. So one of the things I'm interested in doing is whether you can start altering the physics of the virtual world.
That's a great idea.
And see how that affects people's perception.
So maybe you take a ball and it flies.
Or you could find out where when people start to notice. I mean, that's one of the things that I'm interested in is the bounds of perceptual memory. Because we often think of sort of Bayesian thing now. It's an old idea, really. That it's our memories for things are encoded not as discrete things, but are encoded as distributions.
Right.
And there's a model of timing I use called scale expectancy theory. So if I give you a duration to remember, then we think it's stored in reference memory for long-term memory, because you're going to need it for more than one trial. And the way we model this is that it's encoded as a normal distribution. So when I ask you to recall that duration, you go into your distribution and you pull out a memory, and it'll be somewhere in that distribution. So most of the time it'll be around the mean. Sometimes it's a lot. On rare occasions it's a lot longer. On other rare occasions it's a lot shorter than what I gave. And if you model humans' performance on a particular timing task, where they have to have you give them a duration to remember, and you get them to compare it to other durations. You ask them, is that the same, yes or no? To model their response, I won't go into the whole model, but if you have their memory as being a normal distribution, this works very nicely.
Oh, that's fascinating.
It also helps you to model biases. So young children systematically remember durations as being shorter than they actually were. So there, you're not talking about the spread of the distribution, you're talking about where the mean of that distribution is. So you can change the mean of this distribution, and you can change the width of this distribution. So you can model the memory being more fuzzy, or you can model the memory being distorted in some way. But I wonder whether all memories for sensation are like that they're stored as a distribution. And I'm interested in what the limits of that are. So for example, when I go into my office, so my office wall is this colour.
Yeah, white.
Yeah, sort of not white colour, whatever it is. But if the janitor came in, I don't say janitor, they're American. Yeah. If someone came in each night, and each night they made it slightly darker grey. At what point will I come into my office and go, what's going on with the wall? So if they come in once, I probably won't notice it. But at some point, I will notice it.
Yeah.
So it's probably that my memory of that sensation has some kind of distribution. And it's only when it's outside of that distribution that I realise that there's something wrong. Or I update my memory of what it is. And this is off the wall idea, really, but I wonder.
No pun intended.
Yeah, that's very good. Yeah, I wonder whether all sensations are like this. Actually, no, I teach on first year sensation perception. So this is something I think about a lot because it's fun to think about. So we know that a lot of what the brain does is predict things. So before I pick up this can of Coke, I have a prediction or an anticipation of what that sensation is going to be like. And probably when I pick up the can of Coke, I'm not really feeling the Coke. I'm not really feeling that sensation. As long as it falls within that my expectation, then my brain doesn't really pay that much attention to this sensation. But if I was to pick it up and it was freezing cold, then it's outside of the bounds of that distribution. And you wonder whether a lot of the time we don't really feel sensations, or that, or they don't really enter into our.
That's really interesting. So tell me if I'm understanding it correctly. It's almost as we're just recalling previous experiences of that Coke bottle. Yeah. If it's within a certain range. Yeah. If it's fiery hot, then I can start paying attention to it because it's so far outside of my expected bounds.
Because it's novel, or even I wonder if when something is goal related, that plays in as well. Because I remember hearing someone talk about like, okay, I'm going to challenge you to find all the yellow things in the room, and then they say, well, I'll count all the yellow things in the room. They might say like 5, and then you say, okay, how many red things did you see? And then I don't really know, and then you get them, and then they find 2. But the image on their retina was the same for both of the tasks. Yeah. But they had a different goal in both of the tasks, so they perceived completely differently both the tasks. I guess that's different from what you're saying about it being novel or being surprising. But I wonder if those are just kind of 2 situations that would lead you to perceive something.
Yes. So you got a top-down process going on there. Right. One is motivation, and one is expectancy. But the other thing that makes me suspect this is maybe the case is that. So I've read when people take LSD or other mind-altering substances, one of the things that they're often interested in is sensation. They're interested in the yellowness of this. How yellow this chair is. Or it feels amazing. And maybe that's because the substance has interfered with this expectation feedback. So it feels amazing because they're actually feeling it. They're actually paying attention to how yellow it is, or whatever it is. Whereas a lot of the time we're kind of stuck in this rut of just experiencing the same. Right.
There's even a term for it. It's the default mode network. That you have a certain default way of interacting with the world that can get upset via psychedelics. That was something that was really interesting.
Okay, I didn't know that. Okay.
Yeah, so in cases where, say, a veteran who has PTSD would take a psychedelic, they have a certain way of interpreting the world, and maybe in their case, it's a very negative and kind of self-effacing way of looking at it. And that's just the way that they interpret things by default. So maybe in the same way that you pick up the Coke and you already know what it's going to feel like, maybe they know what they should feel like as well. And then this experience, and in preliminary studies which are going on right now, they're showing that it can upset it permanently,
Right.
so such that some people quite literally see a recession in depression rates.
Interesting.
So it's really, really
Okay.
fascinating
Right.
research into that. And I think that when it comes to understanding perception, to me, there's few things as interesting as psychedelics. So
Okay.
I'm curious if you've gotten any experience into that in a scientific capacity.
No, I mean, there is a small literature, go back to time perception, there is a small literature about alcohol and drugs and the effect on time perception. Although,
amphetamine earlier.
yes, so yeah, people will report that time slows down with amphetamine, which fits into the idea that the internal clock is sped up in some way. There's an issue though, because alcohol and drugs, it's hard to divorce them from the situation in which they're taken. But there has been some work taken. Alcohol, for example, it's normally a social situation. So is time flying because of the booze, or is time flying because you're down the pub?
If you were alone at home, would you feel the same way?
But there has been some work done on that, and it does seem as if alcohol does make time slow down, even in a boring laboratory situation. And THC, the active ingredient in cannabis, seems to slow time down, which actually means it's speeding up the internal clock, which seems counterintuitive.
Yeah.
And there's some amazing experiment. If you get away with it in the 1960s, there's a I don't know the name of the author, but my memory's not very good today. It's Tinkleberg. That's a funny name. Did just an experiment in the 60s where they got people really, really drunk and really, really high.
Simultaneously?
Yeah.
Yeah.
And they found that so the cannabis went in one direction, the alcohol went in the other direction. If you gave them both, it cancelled them out.
Oh, okay.
Yeah.
Interesting.
So that's quite.
So there's no point in taking both cannabis and alcohol.
Well,
in other words,
it depends whether you want to affect your time or not. Yeah.
That's a discussion there.
That's been some work on that. A previous PhD student of mine, Ruth Ogden, at Liverpool, she's now a professor at Liverpool. She did some work on drug. She documented people's drug experiences and saw whether they related to time speeding up or slowing down. So there's been some work on that. It's quite interesting. Yeah.
That's fascinating.
Yeah, that interests me because we were discussing this a little bit the other day. I think that's why I came up with conversation, the issue of psychedelics, because I guess we were talking about how it might, I don't know, maybe it inhibits the kind of, or it just disrupts the cycle that you have of perceiving things based on your expectations and based on the top-down processing. Yeah. And I wonder if it also inhibits any other aspect of your perception, so that you, because we talk a lot in perception about how you see things in terms of their shape and comparing it to like icons in your memory. So I wonder if certain drugs kind of inhibit that top-down processing, so that things just become like
new again.
Yeah, they become brand new. Yeah, and I wonder if that plays into how you see things completely differently. And I wonder if that's how you even have hallucinations. It's not necessarily that you're seeing something that's not there. You're just seeing the things that are there in a completely different way, and that you interpret it completely differently. That might be a misinterpretation. It might be that whatever's happening in the dopaminergic system or anything like that causes you to have completely made up perceptions. But yeah, I'd be interested to research that.
Yeah, and although I mean, you can understand why it would be hardwired in for this to be the case, because otherwise you'd be overwhelmed by sensations.
Of course,
which would not be useful.
Yeah. Or if you're too interested in looking at the shape of a lion, then you're not going to try to avoid it.
It's not going to get you anywhere.
Yeah.
And also your brain has to make millisecond decisions about whether something is safe to sit on or safe to grasp. Or so having a hardwired prediction is actually very useful. But from a hedonistic point of view, then it's quite interesting to try and break that. Once it actually concentrates on the thing.
Yeah.
We do this in other, not just psychedelics. We do this in other ways. If you concentrate on the food you're eating, you actually savor the thing. Actually concentrate on the. And we set, we indulge in that. That's kind of the reason why we go. One of the reasons why we eat out at restaurants or we enjoy eating out at restaurants, is that you're actually paying attention.
Yeah.
A, because you spent a lot of money. but B, someone who's really good at this, it cooks you this meal. So you really pay attention to what that sauce tastes like. You taste this, it's amazing. Mm-hmm. So you're trying to break that, rather than just shoveling the thing in, which is normal.
Absolutely. I was going to ask earlier about, because we can talk about, obviously with substances like LSD and others, psychedelics, there's a huge challenge there in terms of just studying it because of the legality around it. But then, as if the framework is the thing that it's giving you, these psychedelics, is the ability to kind of break a baseline assumption you have around the world, that almost enhances perception to a degree, or at least your presence with the perceptual input and kind of your experience of it. I was going to ask if you've read or done any work with mindfulness and like meditation and practices that really try to bring that presence back to a moment, and if that changes perceptual output and kind of like the feedback you get from people when they're experiencing something, if that's at all kind of alters their ability to recount things about it, or time perception during it, or just other perceptual output.
That's an interesting idea. Short answer is no. I've done some stuff on mindfulness, but not related to time perception. So I have a side interest in music psychology. Mm-hmm. So we did some work at RNCM. This is the side. We did some work on performance anxiety.
Okay.
So obviously they have students over there having to take exams and do performances all the time.
Yeah.
And, a lot of them apparently take beta blockers. And it's become a kind of endemic problem. They're not always prescribed. And all this
kind of stuff. I see.
So we were looking to see whether you could use mindfulness to reduce performance anxiety. That's unfortunately we applied for a grant and didn't get it. we did a pilot study on piano students, and we got to do a sight reading task. And what was interesting about it actually was we thought we would have difficulty inducing anxiety because it wasn't a real exam already. But that wasn't the case at all.
Okay.
I don't know if you've ever learned something. I learned piano for a few years, and sight reading is horrible. It's like just given something like play that, and you have to do it for the exam. It's awful. But even these elite pianists at the RNCM, they hated it as well.
Yeah.
Can I ask, how did you measure the anxiety in that paradigm?
By their by their rating, but B, by their performance. So we had two conditions. One where they had a mindfulness session immediately before the performance, and one where they didn't. And they were looking to see how they rated their own. But we also took measures of heart rate. And we also got them to do a timing task as well, so I was interested in whether they affected their...
That's interesting.
And
it does seem to fit in with your ideology of taking psychology into the real world, because you weren't in a lab. You were just with actual pianists in a context where they were supposed to perform at their best. That's really interesting.
Yeah, because I was interested in whether it would affect their sense of rhythm or sense of time. But it's interesting though, because part of that anxiety is something that some people crave. I used to play in a rock band, and that buzz of being on stage was the thing you were in it for. But you get
that thrill of it.
But when other people like you got to a point where it actually interfered with their performance.
Yeah. So in some ways, and I've heard this in a few different high-performing artists who might go on a stage, that at some point they just lose themselves as they're going on stage. They just focus on what's going on around them, and they actively kind of put themselves in that state. And I think that kind of fits with Olivia's point about mindfulness and trying to get out of your head, so to speak. And so I'm curious, pivoting a little bit, I suppose, in your previous experiences in the rock band, do you think that there's any lessons that kind of transfer over into your experience as a now psychologist, essentially?
Well, I was doing the two at the same time. So it was only a few years ago that I left the band. I don't know. Is there anything that transfers across? That's an interesting question. I don't know. I don't know. The performance thing is interesting. I've been lecturing for a long time.
Yeah.
I've been lecturing 25 years. And I remember the first few lectures I gave being absolutely petrified. The first lecture I ever gave was a class of mature students.
I see.
Teaching them biological psychology at a night class. Now, I just graduated.